Welcome to the video ferritic grades. In this table you see the list of ferritic grades specified by the international standards and the commercial standards. So you see for each grade the designation, the minimum properties, yield, ultimate tensile strength, minimum elongation, then a quality description, and then you see the MQI referred to the minimum properties on the minimum thickness that is not larger than 30 millimeters. After you see the MQI star, that is the ratio between the material quality index associated to the minimum properties of the standard in the medium wall thickness from 30 to 60 millimeters, and on the last column you see the same ratio from the minimum between the minimum properties associated to the material quality index associated to the minimum properties on the large wall thickness above 60 millimeters divided by the reference material quality index in the lowest wall thickness. So the last two columns gives to you an idea of the thickness sensitivity of the different materials. Some of ferritic grades are not defined on the medium and largest size because they are typically dedicated to uniform and low thickness applications. So in the international standard you find the specifications for grades that require a given Sharpie minimum impact energy at -40. These are typically quality grades with a low silicon and low manganese content. Same, but at a -20 with a different lower Sharpie energy required. Then, since the old times, some ferritic grades with a higher silicon content have been introduced in the market, especially for automotive casting purposes. The mission was to avoid to enter into the field of ferritic-pearlitic that we know have a scatter in harness, a possible scatter in harness, and so started to increase the yield strength by increasing the silicon content. And this was defined in the FIA standard and also in the Cibodur grades. But this was not enough, and it happened that starting from practical foundry needs of recycling the returns, in the 90s developed some high silicon grades of 3.4–3.5% that traditionally was believed to be brittle. This material was also even in the automotive industry was well accepted because it was avoiding the need to use ferritic-pearlitic grades with the better machinability associated to the uniform and constant hardness. But at the end, this was not enough, and grades have been developed by research programs with a high, very high silicon content, 4.3, with a grade of 600 megapascal ultimate tensile strength and 10% elongation. But this grade that shows a very good combination, yield and elongation in uniaxial tensile test is a brittle material when triaxiality is pronounced, and needs to be approached very carefully with a very, very careful and responsible design. A paper published by Werner Menke of Georg Fischer show in the top left figure and bottom left figure the result of a Rosen test with measuring the ability of material to absorb energy at sufficiently high strain rates, where it is shown how a ferritic-pearlitic grade with a normal or low silicon is able to perform better than high silicon grade of the same yield strength. At our company, we made also other tests that you see in the top right diagram, using a ASTM E399 CT compact specimen with outside groving, and where we tested the energy at the fracture of this specimen with conventional pre-cracking, fatigue pre-cracking, and calculating the so-called KEE, so the equivalent stress intensity factor that was making with the same strain energy density and equivalence principle, and where you see there that this material 610 high silicon is the worst performing in this case, and it is very, very below its performance compared with the IDI having the same yield strength. On the market, you can find also some grades, ferritic grades with lower quality that we call Q2 and Q3 ferritic. These are defined with a lower elongation requirement because for many applications a high elongation is not necessary, and so the purchasers can save money by enlarging the supplier platea, and so to look to the best prices with a lower material quality index. This is, for instance, the case of so-called ferritic grades that tolerate some percent, 10% or 20% of pearlite given by a manganese content that is not so low as typical for ferritic grades.